Hey everyone, Mr. Newman here, and we're going to learn about trig of any angles. So let's get started. First of all, we need to know this new vocabulary word, a reference angle, and that is simply the angle that is to the nearest side of the x-axis. Let me show you some examples because it's easiest to see with examples. So let's say I've got an angle of 300 degrees. The reference angle is to the nearest side of the x-axis. That's the positive side in this case. So the reference angle right there would be 60 degrees. For a negative 100, an angle like that, the nearest x-axis is the negative side of the x-axis, so that would be a reference angle of 80 degrees. For 7 pi over 6, that's that angle. The reference angle would be to the negative side of the x-axis again, that's just pi over 6. So it's always the angle between our ray and either the left or the right side of the x-axis, whichever one is closer. So let's, now that we know that, let's go on and talk about how do we find the 6 trig functions for any angle. Let's say we've got a point, x comma y. In this case, our x is negative because it's to the left, and our y is positive because it's up, but it could be in any quadrant. I want to draw the ray, or the line segment that connects that point to the origin. And I'm going to make a triangle that's on the reference angle side of that line segment. So notice I made it so that one side is always with the x-axis, one leg of the triangle. That will be our x value, because that's how far left you go to get to our point. And the other leg will be our y value. That's how far up you go. The R on here is the hypotenuse, and we call it R because it would be the radius if we made a circle. You can picture, like, for example, not necessarily the unit circle, but any circle, if I drew a better circle. That R is the hypotenuse, and we can use the Pythagorean theorem, because it's a right angle, to figure out what R is if we have x and y. So x squared plus y squared equals R squared. Likewise, if we knew what R was, we could figure out x and y. We're going to get to that in a moment. So now we just need to, you need to know this one other little secret, and that's if our angle is theta there, then sine, cosine, tangent, cotangent, secant, and cosecant of theta are all equal to the respective functions of using the reference angle and including whether the point is to the left or right and then up or down. So let me explain that a little more. For example, if we're looking at our angle, and this is the reference angle right here on the inside there, sine of that reference angle is opposite over hypotenuse, so katoa. So y over r is actually the value of sine of theta. Now notice here y, it would be positive, and r is always positive, so sine is going to be a positive valued function. Cosine, however, in this case, since cosine goes left, that would be negative, and that's the trig function sine is simply, once again, we're using the reference angle and figuring out the SOHCAHTOA, which sides are involved, which sides are the ratio, the output of the cosine function. And if it's to the left, we would just make it negative, and if it was down for the y, we'd just make it that negative as well there. So I'm going to go ahead and fill the rest of these out. One other trick is to know that tangent is sine of theta over cosine theta. That means that tangent of theta is y over x. Now, whenever you do these quizzes, you notice I'm writing up here, I would always recommend writing out all 6 trig functions in order and drawing the lines for the reciprocals. I call that the reciprocal rainbow. In other words, you notice sine is the tangent's the reciprocal of cotangent, cosine is the reciprocal of secant, and sine is the reciprocal of cosecant. So if I have these first 3 on the left, I just know that cotangent is the reciprocal of tangent, so cotangent of theta is x over y. Just flip tangent of theta. You could do the same for cosine to secant, r over x, and same for sine to cosecant. All right, so those are our definitions. Let's get to it and start doing this on an actual problem. So find all 6 trig functions for a ray with the point -3, 4. Well, That blue line there, that's our ray, and this is our theta, okay? Our point is -3, 4. So first of all, I want to find r, okay? I'm going to use the Pythagorean theorem for that, and r ends up being 5, so I'm going to label the hypotenuse as 5. Now that I know that, there is theta, and we can simply use the red reference angle there and figure out all 6 trig functions based on those 3 sides. Now notice they're not quite sides of a triangle because I'm using this side as -3, and distance can't actually, or length can't actually be -3. But if I think of that as the point that I'm using, then these will work out. So sine is opposite over hypotenuse, 4/5. Cosine is adjacent over hypotenuse, -3 over 5. Tangent of theta is 4 over -3. And these last 3 are just reciprocals of the first 3. We flip each one. There we go. We've got all 6 trig functions for a given point. Let's now take a step further and make it a little bit trickier. Let's say I know one of the trig functions. So we know that tangent of theta is -5/4. Well, the TOA, tangent of theta, is opposite over adjacent. So I know that either the sides are going to be -5 over 4 or going to be 5 over -4. That's what -5/4 could, that's how we could get that one way or the other. So either I know that the point is up here on the top left in quadrant 2, where x is -5 and y is 4, or I know that we have to have our point in quadrant 4, where x is +5 and y is -4. Any of the others will have the wrong tangent value. So what I'm going to do is we also need to keep this in mind. Cosine of theta is greater than 0. Let's first find out what r is equal to, because it'll be the same in either case. When you square a negative number, it becomes positive. And so we know that r has to be the square root of 41. So either we're going to use the bottom right triangle, where that square root of 41 is the hypotenuse there, or we're going to use the top left triangle, where the square root of 41 is the hypotenuse there. So let's now think about cosine of theta being greater than 0, and what this means. This is going to help us figure out which of those 2 triangles we're supposed to use. Cosine is adjacent over hypotenuse, and because the hypotenuse is always positive, then as long as the adjacent side is positive, then we are good, and that's the triangle we want to use. Well, look right there. This right here is our reference angle, the inside, so the adjacent will either be 5 or -5, and we want it to be positive, so we're going to use this triangle right here. So we can cross out that other triangle. And now we know that sine of theta is opposite over hypotenuse, so -4 over root 41. Now pause right here because root 41 in the denominator is not simplified, so we do need to simplify that. The way you simplify that is you multiply the top and the bottom by the square root, and we get -4 root 41 over 41. I am going to write up the first fraction each time though, because that's going to help us when we get to the reciprocals. So that is the final solution for sine of theta. You need to make sure you notify that, or make a note of that. Same with cosine, we're going to need to simplify it, and it's 5 times root 41 over 41. I already have tangent. Cotangent is just the reciprocal of tangent, so I know that's -4/5. Secant, you notice where I got that? That's the reciprocal of cosine, and that's why I kept the first fraction written, because now that I've flipped it or found the reciprocal, now the square root is only on top, and that's what we want. We don't want the square root on the bottom. So that's that value, and same with cosecant, which is a reciprocal of sine of theta. All right, let's do one more set of problems here. First of all, you need to know that these 3 problems, especially the top 2, but even the third one, these we need to be able to be done quickly. I'll go ahead and warn you that the calculus teachers give pop quizzes on these early and frequently because they expect you to have these memorized. So cosine of 4 pi over 3. Let me show you how to figure this out very quickly. What you do is you have your unit circle memorized, so you know that this angle is 4 pi over 3, and you know that that's -1/2 and negative root 3 over 2. Once you have that and you know that point, cosine is always the x value, so cosine of 4 pi over 3 is -1/2, and we're done. Let's do the next problem here. This is similar, we need to recognize where the angle is. Negative 210, that's coterminal with positive 150. So we need to know that, okay, when we have positive 150, that's negative root 3 over 2 for the x value and positive 1/2 for the y value. Now tangent is opposite over adjacent. So I'm going to use 1/2 divided by negative root 3 over 2. But once you do this a few times, you'll see, oh, those divide by 2's divide out. So we get negative 1 over root 3. We need to simplify this, get the square root out of the denominator, so we know that's negative root 3 over 3. The last one, cosecant, if you remember, is, well, first of all, 11 pi over 4. That is greater than 2 pi, so we can recognize that when two angles are coterminal, in other words, when they are representing the same angle around the circle, then all 6 trig functions are equal. So 11 pi over 4 is the same as 3 pi over 4 when it's the input of a cosecant function, or any function, any trig function for that matter. The way I got that was I just subtracted 2 pi. In other words, I subtracted 8 pi over 4, and I got this angle, which I do know where that is located around the circle. That's located right there in quadrant 2. I know that the two sides are root 2 over 2, and I know that the x will be negative because it's going left, and so the y is positive because it's going up. So one other tip is to write your reciprocal rainbow at the top of your quiz when you get it. That should be the first thing you do. That way you have all these memorized. And we know that cosecant is the reciprocal of sine, so this is the same as 1 over sine of 3 pi over 4. And we know that is root 2 over 2 from right here. So 1 over root 2 over 2, let's just take the reciprocal, and we can simplify that, multiplying root 2 over 2 to get the square root out of the denominator, and that is equal to root 2. All right. So last thing we got to do is figure out how to use a calculator on some of these. This will be the only kinds of problem that I'll have you guys use a calculator for. But what you have to know, the reason this is not just a simple plug it in is because secant, there's no button, there's no secant button on the calculator. So you need to know, oh wait, secant is the reciprocal of cosine. Therefore, we're going to type in the calculator 1 divided by cosine of pi over 9. Now, I need to pause here and show you guys something about the calculator. The calculator does not know whether you're typing in degrees or radians. You have to set it in that mode. In other words, there's no little degree symbol button on the calculator. We have to change the mode of the calculator because that's going to change whether the calculator reads it as a degrees input or radians input. So here's how you do that. First, you want to click on the mode button to show which mode you're going to do. Then you want to go down to either radian or degrees. You see it's the third row there, so you're going to click down button and then right if you want to change it to radians or left if you want to change it to degrees. And whichever one is highlighted, you can click enter to highlight it. Okay, whichever one is highlighted, it toggles between radian mode, this is radian mode being highlighted here on the left, and degree mode being highlighted here on the right. So you need to make sure you're in the right mode for whatever the input of the function is, and this is a common mistake. So look right here, pi over 9, that's radians. So the first one you're going to do in radian mode. The next one, there's a degree symbol, so you're going to do that one in degrees, and notice that's cotangent, so you have to type in 1 over, or 1 divided by tangent of 410 in degree mode. This third one always throws students for a loop because there's no degrees and there's no pi. Well, remember, pi is a constant. That's not a unit. So there's no degree symbol there. If there's no degree symbol, you know it's going to be radian mode. All right? Just because there's no pi there, that doesn't mean it's necessarily not in radian mode. In fact, it will be in radian mode whether there's a pi there or not. Pi's are just there to help us remember which part of the are there to help simplify where on the graph or where on the graph the angle is. But just radians do not actually have a visible unit. So if there's no unit on an angle, it will be in radians. All right, thank you for watching, and come to class, certainly type those 3 in, try to find those 3 values, and you can compare that with your classmates. Thank you for watching.